Hey, and welcome one and all. This is Coach Jay, section 11.2. Day one, we are closing in on our final sections within AP Stats, really our final sections leading up to our test, and wanted to start off by going over a few things in regards to what we did with the activity, and then also for those that weren't here to be able to hopefully go through this with you together. If you haven't yet done so, I would come in at some point and make sure that you take a picture or write down the Chapter 11 chi-square test flip chart. I kind of have it posted right up on the main board here. That way you could kind of access it, look at it, make sure that you have all of your questions answered regarding the three types of tests and how we approach those there. With that being said, let me go over this and hit on a couple of key points, and especially since most of the math part of it has been taken care of. So we're going to do that together, and we'll rock and roll. Now, before, remember that we had this idea of a chi-squared goodness of fit test, that when we talked about it, the activity we used was our M&M activity, where we had an M&M company state that there was a given proportion of, or a distribution of colors. So 14% were brown, so on and so forth, all the way through red and all of the colors. So M&M stated that this was true, and what we did was we sampled one bag. So we took a sample of M&Ms, and we sampled it, and after our observation, we compared our observations to the expected claim, right? And once we did that, we compared this to the claim, and then we said, based upon our p-value, was this statistically significant to reject the distribution, and or was there insufficient evidence? Was it not convincing to reject the null hypothesis of the fact that the distribution, as was claimed, was in fact true? So what we are doing this time, or what we did do rather, was we looked at the chi-squared goodness of fit test, where we had one variable, which was the color, and we took one population, which was our given sample, or for all M&M bags that are there, okay, or all M&Ms. Well, this time we're going to move past this, and we're going to go into this new 11.2 section, where we're going to take two different types of gummy bears. We have the Haribo, or Haribo, however you say it, and the Walmart brand. So we have two different populations. And instead of having only one, now we've got two populations, and now we're going to compare the colors of gummy bears between Walmart and Haribo, or Haribo, whatever you want to say there, okay? So therefore, we have one variable, the color, within two different populations. At this point, we're going to move in section 11.2 to where we're going to be assessing this using two-way tables, a little bit different, okay? So without further ado, let's get started. As we assess this, the red numbers, 37, 24, 23, all the way down to 107 being the total amount that we sampled with Haribo. And then we have the Walmart brand of 26, 8, 12, 14, and 17 with a total amount of 77. What we did was we looked at both of the distributions within Haribo and with Walmart, and we put those down as we observed them. So the red numbers are the ones that we observed. Really, the red numbers are the ones you're going to get on an FRQ on your AP exam, okay? So the red ones represented the observed value. Notice that there. Now, as we kept going, we noticed that there were two different samples that we took, right? We took two samples from two different populations, one being Haribo, one being Walmart. And we had one variable, which was the color of the distribution, and as we compared those colors from two different populations. Now, as a class, we wrote down our hypothesis, the fact that the color distribution is in fact the same for Haribo and Walmart gummy bears, okay? The alternative, though, was the fact that the color distribution was different for gummy bears from Haribo and Walmart. That was the alternative hypothesis. And what we're going to do is we're going to compare this at a sig level of 0.05, okay? Now, I'm going to get my calculator pulled up because we're going to come back to this. And what we did then is we went backwards to our observed values, the red numbers. And in order to calculate the expected values, which you'll have to do on the test there, in any AP exam, is when you have a two-way table, we had to get these blue values, which represented the values that were the expected from our given observations. So how do we solve that? Well, what we did was we took all of the numbers that were observed, and let's say we were looking for the expected value, which is the blue numbers, of the Haribo red. To do this, we take the total of my row and then total of my column. We multiply those together, and then we divide it by the overall total of all of the gummy bears that we sampled. So we take the number here, multiplied by the number here, and we divide it here. So we say the row total times the column total, and we divide it by the table total, which was just all of the gummy bears that were there. When we do that, we get what we call our expected counts. Okay? Our expected counts. Now remember, we want to think proportionally about what the expected amounts are if the distribution is the same. And so we are assuming that they're the same. So we have to understand and think proportionally on this. And so that's how or why we did it this way, to be able to get what we would have in our blue values. So in the second chart, I put it on the same chart, but because they're different slides, I wanted you to see the difference. The red numbers are the observed, whereas the blue numbers are now my expected. Okay? Those are now my expected numbers that are there. Okay, so the question then becomes, what do we do once we fill out the expected chart, and once we know our observed chart, what do we do now in order to solve for this chi-squared test? Well, it's a great question. To do this, let's try to go through all our conditions and see if we can solve this. Try to wrap it up within 10 minutes to be able to get this within your notes, all right? So let's talk about what we would do in our state problem. We have our null, we have our alternative, right? We already stated the null is the color distribution. And you already put this on the previous page, but just in case, the color distribution for Haribo and Walmart is the same. Remember our SIG level 2? It's 0.05, so just a heads up on that, okay? And over here we would say the color distribution for Haribo and Walmart is different, okay? Different. Okay, boom. We got our hypothesis, all right? So then we go into testing the different claims that are here. We have 3 different conditions that we check. One of which I am still trying to figure out in terms of when we use it, when we assess it, but I'll get back to you on this. We're just going to put down what we would put here. Random is, we would say we randomly sampled the gummies, okay? It was from one random pack. Now, you could technically go against that, but we're just going to say that it was, in fact, random. The second one is large counts. Okay? Large counts would tell us that we have all expected values. All of them. Sorry about that. This should be right here. All expected values are greater than or equal to 5, right? You could also say that the least one, the least expected value, again, as you see all the blue ones, the least one was, you could say orange or white from Walmart, right? And you could just say that that one's greater than or equal to 5, which is the least one. Therefore, all expected values are greater than or equal to 5 if you so chose. And then independence. This is a little bit different. I know that we're still up in the air of when we use this. I've seen some use it, some not use it within my conditions. I'm going to put it down here for now and provide a little bit more feedback on when we use it. But right now we'll just put that, we're just going to state that the Haribo total sample, which was in this context 107 and 77, okay? So we would say 107 and 77, this is the Walmart one, is less than or equal to 110 all Walmart gummies, right? Gummy bears. I should put gummy bears, my fault. And 107 is less than or equal to 110 of all Haribo gummy bears, okay? Cool. All right, so we want to make sure we say state independence, and there we are. So here's where we get a little bit interesting. Let's first draw the picture because this is important. The picture starts at 0, same thing. Here we go. We got our p-value. We've got our chi-square value. So this is our p-value. Our chi-square is that specific number. We also remember that the degrees of freedom, here's the kicker, okay? Because there are we don't just have one population, we have two. We would state that the degrees of freedom is rows minus 1 times columns minus 1. So if we go back here, and what we mean by that, exclude the totals, right? So excluding this and this one here, okay? We would do the Haribo, okay? So Haribo and Walmart, those are 2. So 2 columns, minus 1 is 1. And 5 rows, minus 1 is 4. So 4 times 1 is the degrees of freedom over here. So we would say, right here. So we would say 4 minus 1 times 2 minus 1. So this would be a total of 4. So therefore my degrees of freedom would be 4. Okay? Make sure you show that somewhere. It's important to show that at some place there. Okay? Now the do phase, remember that this is a chi-square test of homogeneity. Homogeneity here. The reason why is because we have 2 populations, 1 variable. Okay? When we have 1 and 1, that's the GOF of chi-squared. Okay? Now the specific formula is still the specific formula of old. We have the sum of the observed minus the expected squared divided by expected. That's important. We put that. Now we want to make sure we put 1 that our chi-square value is equal to, and this equals chi-squared, right? Our chi-square value is equal to, and what we're going to do is just going to put in 1. So what we could do is just put the observed minus the expected squared divided by expected plus ... plus the last one, observed minus expected squared divided by expected. And so the last one would probably be, again, we have to do them for all of them. So this might be the Walmart white gummies. And maybe the first one we did was like the red ones, right? So we could just say this would represent Haribo red, okay? So the question is how do I do this on my calculator? You can actually do, if I went back here, you can actually do all of this within by hand. So where you would do observed minus expected divided by expected, observed minus expected divided by, or then squared, divided by expected. Do it for all 10 of those, okay? However, that would take a long time. So how do we do this? Well, this is where we're going to take this just a little bit deeper. And in order to do this, we're going to go to second, x to the negative first, which is a matrix, okay? And what you're going to do here is you're going to plug in 2 different things. First off, the A is going to be my observed, and the B is going to be my expected. So in the observed, okay, I'm sorry, I should have gone backwards. We're going to edit it, so that's my fault. So we're going to edit, go over to edit, then go to the A, okay? And within this matrix, you are literally going to put the exact numbers that you saw within your matrix, okay? So this would be like a 2 by, I'm sorry, this should be the rows first. So the rows would be 5 by 2, okay? All right, and so what we're going to do is just literally plug in the values of what my observed would be there, okay? So let's see if I can come back here, and I'm going to put this lower here. So I'm going to do the red first. I'm going to minimize this. And then the B is going to be the expected, which would be the blue. But we're going to go 37, enter, 26, enter. So all I'm doing is literally just plugging this in. That's all I'm doing. Okay, so if you're like, what is he doing? Just literally plugging in the exact values that you see there on the side. Hopefully you see that there. They got 10 and 17. Perfect. Okay. So we've got that, and then I'm going to go to second x to the negative first, and for my edit, I'm going to go to B now. Still going to go a 5 by 2. Okay. And this time I'm going to plug in my B values, so we're going to go 36.6. Go just a little smaller here. And just trust me, it's actually up there just so I can see this here. 26.4, 18.6, 13.4. And again, maybe you did it in the other class where you didn't have all this as well. And that's okay too. Maybe yours was different values is what I'm saying. 11.3, 15.7, and 11.3. Okay? All right, so once I get to this test here, I'm going to blow this up just a hair, just so you could see it. We're going to go back to our test by going to stat this time, and this time, remember the chi-square GOF test? That was the one we've already done. Now we're going to go to chi-square test, where A is traditionally the observed and B would be the expected. We're then going to go down to calculate, and when we press calculate, we're going to see that our chi-square test would be 10.6 with our p-value of 0.03. So 10.62. So we've already done, let me do this, come over here. So our chi-square test is 10.62. We'll put this here. So chi-squared is 10.62, which is actually my test statistic right here. And my p-value is 0.03, okay? Now, in conclusion, how would I state that? I would say because p is equal to 0.03 and it is less than our sig level of 0.05, we do have convincing evidence to reject HO, and then tell me what that means. Put a little context to it, right? So if I was to say something like that, I know I don't have room here, but I would say convincing evidence to reject HO, which states that the distribution of gummy bear colors between Haribo and Walmart are the same. We can reject that, right? We have convincing evidence to accept the alternative that they are, in fact, not the same, okay? And then go from there. Okay, what makes this different from a GOF test? The big thing, we have, in this context, two samples from two populations, right? Haribo and Walmart. And which states that chi-squared goodness of fit has only one sample in one population. One population. Perfect. Okay? Hey, I hope that made sense to you. We will look at some of the stuff within the lesson. I'll probably even do this again, at least talk through it. Other than that, I hope you have a great day. Be blessed, y'all. Have a good weekend. Bye.